Just like ordinary variables, arrays can be initialized as well. Think about what that means. What does it mean to initialize an array? You've got an array of, say, 10 integers. Remember, an initialization is setting the variable to have a value at the same place that you're declaring it. So, when we declare a variable, is it possible to initialize it at the same time? Yes, it is. If so, how? What would that possibly look like? So, when you do initialize an array, and I'll show you an example of that in a moment, you actually don't need to specify the size of the array. So, where you might specify that you have an array of 10 integers, you don't need to say that there's 10, because the actual initialization part, where you actually set those 10 values, that will be enough information for the compiler to tell that the array is of size 10. I promise you'll see what that looks like in just a moment. Okay, here's an example. I've declared an array of integers. Notice I have not put anything inside the brackets, the square brackets. There are actually 4 integers in this array. They are 3, 6, 9 and 12. Notice how they're initialized. You use a curly bracket. Curly brackets around all the 4 values, separated by commas, and then you put a semicolon on the end. And that is how you initialize an array. As I mentioned earlier, the 4, in other words the 4 as in 4 elements, is not required here. The compiler can tell that there are 4 elements, and so will automatically size the array for you. Isn't that handy? However, it is possible for you to declare an array of size, say, 10 and initialize it exactly like this, with the 3, the 6, and the 9 and the 12. In other words, you might have an array where there are 10 elements but only initialize 4 of them. So what happens to the other 6? And which 6 are you initializing? Well, you're initializing the first... which 4 are you initializing? You're initializing the first 4. The first 4 get initialized. The other 6 get set to 0. Now, it doesn't say anywhere that you're setting anything to 0, but you are. The other 6 elements, if that happened to be a 10, if I put a 10 inside those square brackets, sorry, I can't do it on a PowerPoint slide. If I put a 10 inside those square brackets, oh darn, let's just go and have a look at it in the source code. Why not? Okay, I'll continue that explanation now that I can actually play with the code. Okay, there it is again. It's an array. Now the compiler will decide that that is going to be an array of 4 integers, because I have specified 4 numbers in the initialization. Okay, it is possible to do this, to say there are 10 integers or any number of other integers, and only initialize 4 of them. In that situation, the first 4 get initialized, while the remaining 6 all get set to 0. So they are initialized. The entire array is initialized, but it only 4 of them are explicitly initialized, the other 6 are implicitly initialized. Of course, if you think about it, it would be possible to initialize an entire array of 10 or even 1,000, let's say 1,000 elements could all be initialized to 0 just by doing that. That explicitly sets the very first element to 0, and implicitly all the other 999 elements get set to 0 as well. So that is the fastest way to initialize an array. It's a very, very fast way of doing that. Okay, that's fairly straightforward. Now here we are back in our multi-dimensional array example, the grid example. Remember that? Okay, now let's pretend that this is a grid of a chess grid. So we'll have to go back to 8 by 8, and this will be 8 by 8. In fact, this is the initialization, so we won't need that at all. And back to 8 by 8 here. Okay, now if I want to initialize this grid, this is initialization of a 2-dimensional grid, I can do that. This is how it looks. Obviously I need to put something inside the brackets. What is it? Okay, I'm going to do that magic typing now, so it'll all appear in 1 second. Okay, so here we are again. and we've through the magic of the pause button, I have done all the typing that is required here. Now I've changed this to an array of characters, so rooks and horses and bishops and kings and queens and pawns, and a space if there's nothing in that square. So this is what I've done. Here's my open curly bracket. I put it down here and I put the closed curly bracket and the semicolon there. Now that's a little bit different to what I showed you before, but I promise you the only difference is the white space. Now it's an array of arrays, so remember from our previous example that every initialization element was separated by commas. So this is separated from the next line, this, by a comma, that comma right there. So we have 8 things, 1, 2, 3, 4, 5, 6, 7, 8. Notice there's no comma after the last one, there doesn't need to be. So we have 8 elements, and each of the 8 elements is an array of its own. So it's an array of arrays. Well, we already know that, and that's how the first element is declared. Okay, so I think if you look at that, you'll see that it is actually an array of arrays initialized simply by extending what we looked at in the last example. Now, I don't know about you, but as far as I'm concerned, this is a whole lot neater and more obvious, and certainly less typing, than doing 64 separate assignment statements, which is what we'd have to do if we wanted to assign each one of those elements individually. I've also taken the liberty of changing the printf down here to a %c. It used to be a %3d. So let's see if that compiles and runs. Compile, okay, and run, and there it is. Okay, fairly straightforward. Okay, so that's a multi-dimensional array initialization. Finally, for the end of this module, I'll show you how to initialize an array of strings. This is our old multi2.c, the array of strings, but I've saved this now as multi4.c. Before I show you how to do this, I'm going to ask a question. What is it possible to do with strings natively in C language without reference to any standard C library functions? What can you do with strings? What does C provide you with the tools to do? Now you may not know the answer to that because you haven't seen the whole C language yet. But have I shown you anything that you can do with strings by themselves that don't require standard C library functions? Remember there's strcpy and strlen and strcat and all those, and there's printf and scanf for reading and writing them. Well, what about just manipulating strings in the code without using any of those functions? The answer is nothing. You can't do anything with strings. Well, I haven't shown you anything. There is one thing that you can do with strings natively. One thing. It's not very much. It's not very powerful. You can initialize a string. That's all you can do with a string natively in the C language. Let me show you what I'm talking about. Let's create a simple string here. We'll call it name. And we'll make it 50 characters long. Okay. That's a string that's called name. I will now initialize that string. You haven't seen this before. This is the initialization of a string. I didn't show it to you before because I wanted to show it to you in this chapter, which is about initializing arrays. Okay, so let's have a look. That's it. That's how you do it. Isn't that interesting? You can't do this. I'm just going to copy and paste this code. Copy and paste, and I'm going to get rid of that and get rid of that. You can't do that. You can't just say name equals mark virtue. You can't do it. The reason is because name is an array, and you cannot assign arrays. You can only initialize arrays. It's not, well, it is consistent, but it's not. I mean, it's a very clear and standard rule, but you'd think surely if you can do that, you ought to be able to do that. And I'd like to be able to, but you simply can't. You just can't. It's one of the rules of C. So, give up any ideas of ever trying to do that. The compiler will probably stop you with an error message. However, you can do it as an initialization. So what happens here? Well, it's a 50 character array, and the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters plus a null, so 12 characters. The first 12 characters are being set, and the remaining 38 characters are all being initialized to what? Well, to 0. Not the digit 0, so it doesn't look like this in memory. It actually, if you recall, the 0 character is the null character. So you get 11 characters that are visible, followed by a null character, followed by 38 more null characters. That's actually what gets set into the name array right there. Okay, so now here we have got an array of strings. So let's see if we can initialize an array of strings. Let's do it this way. Sorry, my typing's not very slow, not very fast. This is how to initialize. There are 5 strings, 1, 2, 3, 4, 5, and there are 5 mentioned here, and each one of them is less than 20 characters. That's good, because it wouldn't fit if one of them was more than 20 characters. You'd probably get a compiler error saying, like for example, if I made this one really long, like that, more than 20 characters, I'd get a compiler error. So I won't do that. But if you recall, I mentioned a short moment ago that when you're initializing arrays, you actually don't need to specify how many elements there are. So I can get rid of that. I can get rid of the 5, and it will create 5 for me. It will create 5 strings of 20 for me. It'll do that because here they are, there's 5 of them. And you might say to yourself, well hang on, not each one of them's 20. Like this one's only 4, well 5 if you count the null, then 3 and 4 and 3 and I don't know, 11 or something. And that's true, but here you've specified that each one of the strings is actually of length 20. So this will be 4 characters plus a null plus 15 more nulls. Okay, I hope you can understand that. So then you might say to yourself, well then can I do this? Can I say I want to specify no size here and have it pick up the size individually? Well you can, but it won't know how long to make each one. So then you say to yourself, alright, well what if I make them all of length 3? Like this. Surely I can do that. It might be apparent that to you and me that these are 5 strings each of length 3, well each of length 4 if you count the null. But the compiler doesn't see it that way. Or perhaps the compiler could see it that way, but compilers don't see it that way. With multi-dimensional arrays, you cannot specify no sizes. You have to specify one of the sizes. In fact, if there was 3 of these, if it was a 3-dimensional array, and that's possible, you must specify 2 of the sizes. You must specify, say, 23 and 12, and you don't have to specify how many 2-dimensional grids we have. But if we've only got 2, then you must specify the size of the inner one. You must. You absolutely must. It is a compiler rule. If you don't believe me, well, I'll show you. I'll compile this one for you. Okay, no errors, 0 errors. Now I will get rid of that 20 and I will compile again. Total errors 4. Elements of array strings have incomplete type. Array size missing in strings. Okay, so clearly we can't do it. We get error messages. So that's about it for initialization. There's really not that much to it. Once you know those rules, you can initialize any sized array that you like, whether it be multi-dimensional or single-dimensional. Thinking about multi-dimensional arrays, how multi-dimensional can you get? Remember I said, okay, we could do this, and then we could do that, and then we could even do that, I suppose. That's a 4-dimensional array, or a 3-dimensional array of strings, if you like. And yes, you can do it. The compiler will essentially let you do it indefinitely. You obviously have to have enough memory to hold these things, and they get awfully big awfully quickly. And it also has to be somewhat sensible to do that. It has to make sense in your head. Now, I've been coding a long time and I've never come across a commercial need to have anything bigger than a three-dimensional array, and even those are very rare. To be honest, I don't even use two-dimensional arrays particularly often, but sometimes. Three-dimensional arrays, I don't know, maybe 5 times in my programming life. In my commercial programming life, I should say. Academically, you can extend them forever just for the academic exercise of it all. Four-dimensional arrays, never. I've never had to code one. It wouldn't be too hard to code one, it's just extending what we already know. But I wouldn't want to, it's just a little bit too nonsensical. Okay, with that in mind, let's close our chapter on arrays and I will pose you some exercises.